Hello students, welcome to the next lecture on the power series. Today we will discuss about error estimates or called as a convergence of the Taylor series. Myself Dr. Garg, working in the School of Mathematics Thapar Institute. You can simply follow my YouTube channel Dr. Harish Garg for finding the various videos on this power series as well as real analysis. So what we have discussed so far, we have ended the last two lectures related to the Taylor series and the Taylor polynomials, and we also give some open questions for you like if f of x converges for all the x or some interval I, then how accurately do the functions or the Taylor polynomial approximate the given function on this interval. Second open questions for you is that for what value of the x we can normally expect the Taylor series converges. So these two answers, these two questions will be solved now in this lecture. So this is the Taylor series. If you have a function f whose all the derivative exists about the point A, then we can define here. We can see this is an infinite series. So if you write in terms of the polynomial, like if I write this apart from the n terms, we call as the Rn. Rn is called as the remainder of the order n, or called as the error term, or we can define like of n plus 1. In order to estimate the error, we generally use the two different methods. The first method is called as the remainder estimation theorem, and this one is the alternating series estimation theorem. So this is already we described in the infinite series lecture. What is the error estimation theorem? So if you have an error, that is a R of n is defined here, then our need in this Rn, your target is to find the n plus 1 derivative of the function fx at the point C, but clearly says that the C is my unknown because C lies between the point A and the x. So how you can compute the derivative of the function at the unknown points? So that is not an easy task. So in order to get rid of this, we will discuss the remainder estimation theorem that will help us to compute this Rn without knowing the value of C. That's why this is quite important in that. There are the two theorems. I quickly recall that. What is the remainder estimation theorem? So if there exists a positive constant m, so that once you will calculate this absolute value of this part, that is a function derivative at n plus 1 is less than of that constant for all the C which are lies between a to x, then this remainder term, that is Rn, is defined like here, and it is called as error term, which is nothing but here. What is that? On the other hand, what is the alternating series test? So if you have the power series or the Taylor series representing in terms of alternating, like the first term is positive, second is negative, third is positive, negative, and then so on, then only this alternating series estimation applicable be. And if I consider Sn with the approximation to the fx, then the error is less than of the absolute value of an plus 1. What is the an plus 1? So an plus 1 is the first unused term after the truncation. So like if you truncate here, then the first unused term is my here. If you truncate here, then the first unused term is my this. And the sign, whether this sign fx, whether the fx is greater than s or it is a less than, that's depending upon the nature of this an plus 1. We will explain this in the help of numerical examples. So this remainder estimation theorem will give you the answers to the open questions. These are my two open questions. So first question is how accurately the Taylor polynomial approximate the given function f. So we all know if I write the Taylor polynomial, Taylor series in terms of the polynomial, we can write like here. So clearly says that, what is the meaning of that? It means this formula is very useful because it gives the approximation. This is my Pnx is my approximation, and the error is denoted as Rnx, both ever in a single formula. Or in other words, you can say when you want to approximate the given function fx to their approximation p of x, then by using the Taylor polynomial, then the error involved approximation is my Rnx. So this is the answer of this. How accurately the error will be approximated. So the answer of this will be Rn. What is the meaning of that? Say if you have the infinite series or the Taylor series of e raised to power x and here, and if you want to approximate up to 1 plus x, then what will be the error? Error will be my of this part. So that is nothing but my Rnx. Second question is when the Taylor series is converges to the function f of x. That's again very simple because this is my Rn. So if you take n approaches infinity, so this part will goes to the 0. And what is the m is? M is my positive number. So it means this will goes to the 0. So once Rn is my 0, so what is the meaning of that? Fx and the Pnx are same. That means the Taylor series converges to the f of x is here. Now we will describe the 9 examples in this lectures, and 5 examples are exercise for you so that you can learn it very simple manner. So let's start with the first one. What is that? Approximate the function e of x, which is given to be here. Use the remainder estimation theorem. You have to estimate the error when x will be less than of 0.1. So there are only two kinds are there. So there are the two types B. The type 1 is when you want to estimate the error, and the second type is when you find x for which error will be less than of their desired goal, whatever the goal is there. So this question is related to here. This we will discuss the second example. So look at that. Firstly, you have to find the Taylor series of e raised to power x. So you can easily derive that as based on previous lectures. You can write here. Now clearly says that this series is not alternating series. Is it alternating series? No. It means the alternating series estimation test is not applicable. So the only applicable is my remainder estimation theorem. So what is the remainder estimation theorem? This is my approximation given to you. So this is called as Px. So how many terms are there? Up to the degree 2. So we call as up to the second term. Now by the definition of the remainder estimation, which can be written like here. What is the R2 is? That is my third derivative over here. So my target is to find the value of here. How you can find that? So that's not an easy task. So what we can do, we will find the firstly error. Error is nothing but the absolute value of this. So the absolute value here. So now we can find the upper bound of this. So we need the third derivative. So we can, what's the first derivative? What's the second derivative? And so on. So what is the value of the f triple dash at the point C? That is nothing but e raised to power c. And we need the absolute value. We can take the absolute value which is here. Now how you can find the value of this? So look at that. How? Because this is a is my 0 in this case. So 0 is less than c is less than x. E raised to power x is my increasing function. So once it's an increasing function, so it means I can write like of this. So what is the e raised to power 0 is 1. This is e raised to power c. This is e raised to power x. So it means this number is less than of mod of e raised to power x. Now what is given to you? Mod of x, it means minus 0.1. X is here. Again, because of the exponential is the increasing function, so we can write like of here. So what is the meaning of this? This number is less than of e raised to power 0.1, which is approximately 1.11. So I can substitute all the value here, which is less than of this number is less than of 1.11. 3 factorial, what is the value of the x is less than of 0.1. So this is the error of this question. So estimate the error. Error will be here when you truncate this Taylor series of e raised to power x up to the second degree. Look what the another one. So for what positive value of the x? Now in this case error is given to you. This is given to you and your target is to find the value of the x. So that is the second kind. So clearly says that this is an alternating series. So once this is an alternating series, then you may apply the alternating series estimation theorem, or you can apply the remainder estimation theorem. So we can use the both method. Firstly, we can describe here what is given to you. That is approximation is my only x. You can see this is my only x. So it means I want to truncate here. So the error will be the first unused term. What is the first unused term is x square by 2. Now it is given to you that the error no greater than of, so can't be greater than of the 10%. It means it's less than or equal to the 10% of x. So I can use the 10% of the x. Can you find the value of the x? Because x is my positive number, so that means x should be greater than 0. So what is that? Mod of x over 2 is less than of 0.1. So mod of x is my 0.2. Because of the positive number, so our lower limit is my 0. So within that number, what is the meaning of that? What is the meaning of that? It means this is the range of the x when you replace the log of ln of 1 plus x with the help of the x, you will get the error as 10%. What is the second method is? So look at the remainder theorem. What is the approximate polynomial is x? You can see that this is the x, x square, x cube, all are the continuous series. So by remainder estimation theorem, error is my R2 because this is my P1, sorry, this is my R1. So what is that? This is fx is P1x plus R1x. So what is the R1 is second derivative over 2. So our target is to find the value of this only. How you can find that? What is the fx is? Fx is my ln of 1 plus x. We can take the second derivative. This is my second derivative. Now c is, now what is the value of the f double dash of c, which is minus 1 over 1 plus c whole square. And if you take the modulus value, which is always be less than 1 because c is my positive number. So if you substitute the value here, this is my less than, this is my 1. So x square by 2 factorial, which is less than of 0.10% of the here. So you can see which is same as that of this. You can solve this, you will get the bounds as here. Look at this is a very important questions for you. So for what value of the x you can replace the cos x by the error not greater than. It means your target is to find the value of x. Firstly, find the Taylor series of this cos x. So point is not given to you. You can see this polynomial is about x0. So you can find the Maclaurin series of the cos x here. Again, this is an alternating series. So we can apply these two methods. Let's start with this here. So your target is to truncate up to here. So the error will be less than of x4. So by alternating series, the error will be less than of x4 divided by 4 factorial. And why it's a positive? Because what is the sign of this x4 is positive. So that's why error is my greater than 0. Now your target is to be find to be x. What is that? What is given to you? Error is no greater than of this. What is the meaning of that? It means error is my less than or equal to this one. So I can substitute the value here, which is the meaning of this. From here you can find the value of the x. You will get the right answer. Look about this one. So what is the polynomial is? This is my here. So which is of the degree 2. I can, okay, what is the meaning? What is the interpretation of this is? It means when you want to approximate the cos of x with this approximation, that is a Taylor polynomial of order 2, and we want to error not be greater than of this, then our target is to kept x should be lies in between this domain. Now look at this same question with the help of the remainder estimation theorem. So whenever you want, now you can see that there is a, what is the coefficient of the x? What is the coefficient of the x cube? x5, they are missing in that case. So then you have to write, firstly you have to complete the series. Now this is a polynomial of up to 2. So I can write this is x square by 2 up to the second degree. So what is the meaning of that? This is my P2. So by the remainder estimation theorem, I can write this is my P2 plus R2x, where R2 is my third derivative of this and error is here. We can take the modulus value of this, we will get this. How you can find the third derivative? So what is the f of x? F of x is my cos x. What is the first derivative? Is minus sin x. What is the second derivative? Minus cos x. Third derivative is my plus sin x. So therefore, third derivative at the point c is my sin c. And if you take the modulus value, sin of c is always be less than or equal to 1. So this portion is less than 1 over 3 factorial mod of x cubed here. So this value is less than 1, which is here. So error is given to be here. So therefore you can say error is my this, you can write here. So from here you can see the mod of x is less than of this. But you can see that both the answers are different and this answer is wrong. But question is why? How do you know that the answer is wrong? So what is the meaning of this? What is the meaning of this range? It means you can take any of the values outside of this x, you will get the error more than of this. So let's try with that. Take x is any number which lies outside of this. Then we can find the value of the cos x and their approximation cos x and their approximation 1 minus x. So therefore, if you compute the error, we can see that which is still less than of here. It means there exists, so it means this is 0.31. So according to this question, it means it will converge to in this interval whose error is less than of here, and outside that it will be more than of 0.005, but which is not true. It means this interval is incorrect. Now the question arises is how we know that this is incorrect. So for that, up to here, so look at that. What is the my P2? So if you consider P2 is my here, what is my P3? P3 you have to consider up to the third degree. So is there any difference between them? Is there any difference between them? No, because P2x and the P3x, that is a Taylor polynomial, this is my Taylor polynomial, are same. So it means they are same. So therefore by the remainder estimation theorem, we can write this as a maximum order P3. However, you can't write this as P2x plus R2x because P2 and P3 are same. So you can't say like of this. So once it is R3, you can find the fourth derivative here. How you can find the bound of this? So you can take the fourth derivative. You can find the value of the mod c, which is less than equal to 1. You can substitute here, which is error will be less than of x power 4 over 4 factorial. Now from here you can compute the value which match with the alternating series test. How do you know that it is a correct? Again, we can take any value which lies outside this domain, say 0.6. If we compute the error, we can say that which is greater than of this. Hence, this is the maximum interval on which the error is less than of here. Okay, look over the next one. So again, you have two targets to find the value of the x. Firstly, find the Maclaurin series of the sin x, which is again an alternating series. So again, there are the two methods. So this is up to the x cube, that is up to the third term. So we can truncate here. Error will be my x5 divided by 5 factorial. And since sine is my positive, so the error will be positive. And what is that? No greater than of this. It means it is my here. So you can find the value of the x from here. You will get as this one. By using this remainder estimation theorem, so firstly because of the x square degree, x square is missing, x4 is missing, you have to complete them. So what is that? This is my cube. So it means this is P3 is given to you. But you can see that P3 and the P4 are same because it's a 0. So what is my fx? Fx is nothing but P4 plus R4 instead of P3 and R3. So now it's a P4, highest order is P4, so you can write here. So rest of the part is simple. You can take the error. Error is nothing but my mode of R4. Your target is to find the fifth derivative of sin x. So you can take the upper bound of this. We can take the fifth derivative. You can find the absolute value which is less than 1. Substitute here. So what is the error is? This is less than of mod x raised to power 5 over 5 factorial. And it is given to be no more than of 5 into 10 raised to power minus 4. So based on that, you can find the value of the x. You will get the same answer as by the method 1. Look about the another one. So firstly, you have to find the Taylor series or the Maclaurin series of the sine hyperbolic x, which is not alternating series. So remember, which is not alternating series. So it means only the remainder estimation theorem is applicable. Only remainder estimation theorem is applicable. So what is that? This is my up to degree 3. So P, firstly, some terms are missing. So you can write in this way. P3 and the P4 are similar because P coefficient of the x4 is my 0. So what is my fx is my P4 plus R4. R4 can be written as of this. So target is to find the value of here. So what is that? Sine hyperbolic. Sine hyperbolic written as this. Take the fifth derivative. You will get this number. Take the modulus value now here. So your target is to find the value of E. It can be written like of E of C plus E of minus C. Now how you can find the value of e raised to power c? What is the value of the c? 0 less than c less than x. Again, exponential is an increasing function, so I can write this number as of here. So what is that? E of c is less than of the e of x, and x is less than of the 0.5, so it is written as of this number, which is approximately 1.65. Now e raised to power minus x, again this will be here. So since e raised to power minus x is a decreasing function, so if you apply e raised to power minus x here, the inequality will be reversed, e raised to power minus 0. So e raised to power minus 0 is my 1, so this number is my less than of 1. So I can substitute this value here, which is written as 1.65 plus 1 is my absolute value of this. I can substitute the value here. Your target is to find the error. X is given to you. You can substitute here. This is my 2.65 divided by 2. And what is our mode of x? It's a 0.5 cube over 5 factorial. You will get this as the answer. Look about the another one. You have to show that when you replace the e raised to power x by 1 plus h, the error is no greater than of this number. Again, very simple. Firstly, write the Maclaurin series of the e raised to power h. Again, this is all the positive series, so we apply the remainder theorem. So e raised to power h is replaced by 1 plus h, that is up to the first term. Clearly says that p1 is not equal to p2 because nothing is there. So we can write the fx as p1 plus r1, where r1 of h is my here. So the target is to compute only f double dash of c, bound of this. So what is fh? This is my e raised to power h. So we can take the second derivative. What is that? This is my here. Again, c lies between 0 to h. Because of the increasing function, it can be written like of this. So it is be less than of e raised to power h, and h will be, h is my less than of the 0.01, so I can write an as of here, which is approximately a 1.01. So this number is my 1.01 divided by 2, h is my 0.01. I can substitute here, but we need to find the error in the terms of the h. So I can write this h square as a h into h. One h I can substitute, other as such. If you multiply them, you will get as a this much percentage, because this number is percentage. Can this number is less than of the 0.6 percentage of the h? Yes, because 0.505 is less than of the 0.6. So I can write it as here. So this is the hence proved. Look at the another example are there. So in this case, you can see there is no need to compute the error. Look at if you read the statement, they are not asking that you have to find the error. They are not asking that you have to find the value of the x for which error is less than of something. Error is less than of something. This is not given to you. Neither this case, neither this case. You have to prove something. So, but you have to use the error estimates. Firstly, find the Taylor series or the Maclaurin series of the sin x, which is an alternating series. So once is an alternating series, you can apply either of the methods. So let's start with firstly alternating series test. So here you can see firstly we can take as a x. So let's say polynomial with respect to the x here, that is my here. What is the error is? Error is my this, and what is the sign of this? Error is negative. What is the meaning of the error? Actual value is my this minus approximate error is my x, that is less than 0. So what is the meaning of that? If this happen, it means sin x, this number must be negative. So what is the meaning of that? Sin x over x is less than of 1. So the first inequality proved. In order to find this x square, since x square is not be there, so we can truncate this series up to the third order. So once it will be there, then again the alternating series test, which will be here. And since this is a positive, so the error is my positive. In this case, what will be the error? Actual value is my sin x, truncation is my x minus x cube over 3 factorial, which is a positive number. So we can solve that. If you divided both sides by x, you will get as this number. So from this equation number 2, from this equation number 1, we will get this as the desired result. So these three questions are exercise for you. You can try it yourself and let me know your answers in the comment box so that you can verify it in with the others one. These are 4 more questions are for you. You can try to solve it and send your answers in the comment box. I hope you can simply learn this concept in very simple manner. You can find my playlist Mathematics 1 channel name Dr. Harish Garg, where you can find the various lectures on the infinite series, power series and the others are. You can like, share and comment this video with your friends. Till then, best of luck students. Happy learning.